And we are live. What is up, everyone? Welcome back to the HackSmarter Twitch channel. My name is Tyler, and we get to hang out this evening and do some more AWS hacking. A special welcome to those of you who have been on Twitch. You watched the previous one, and thank you, Amoeba Man, for saying the music wasn't on. I thought that song that we were just listening to, YouTube won't get this, but the song y'all were just listening to on Twitch is a accurate description of how I feel about learning AWS pen testing. I pulled up the lyrics here. They say this: living in my agony, watching my self-esteem go up in flames, acting like I don't care what anyone else thinks when I know truthfully that's the furthest thing from how I feel. That's how I feel when I learn AWS pen testing, is living in my agony. But we are gonna keep on keeping on and keep going through the very strange and confusing world that is AWS. Let me go ahead and share my screen, and we'll dive into it. Bottleneck said lyrics hit deep. Amina said that's rough. Yeah, probably an overstatement. It is still fun. It's just, I don't know, guys. AWS is confusing. Maybe it's just me. It's probably half and half. But we are going to learn about AWS Encryption Services. We're going to learn about attack and defense techniques in AWS when using encryption services such as KMS and ACM, which I'm actually really looking forward to this, because at Rhino, one of the things that we'll point out is some of this stuff. Like, we actually had a few pen test reports that have gone out in the past, and I'll like QA them, and I'll read about these services, and I'm always like, how are those actually used like in the real world? So I'm looking forward to learning about that. Introduction to AWS Encryption Services. So students will learn basic encryption concepts as implemented in AWS, such as KMS keys, ACM certs, and route DNS verification. Students will learn about common security issues related to using encryption in AWS, including how access to encryption services in AWS can be abused by hackers, that's us, more like script kiddies, at least me, with a little help from Route 53, which is the AWS DNS service. Students will use this knowledge to register a malicious subdomain and associated TLS certificate. That sounds pretty fun. Offensive security and encryption controls. In a typical on-prem penetration test, it is not uncommon to find internal applications hosted on the corporate VPN without HTTPS. Furthermore, it isn't always the case for data to be encrypted at rest. These configurations mean that it may be relatively easy for an attacker to read intercepted traffic if they find an opportunity for attacker in the middle, or that they wouldn't have to hunt for encryption keys if they found the loot. Commonly, orgs that wanted to leverage encryption everywhere had to spend a lot of engineering effort to configure certificates and managing rotation, and I had to do this at my previous role, and it's just annoying, to be honest. And ensuring full disk encryption of hard drives. All of that has changed with the cloud and AWS Encryption Services, KMS, and ACM. So AWS Key Management System. AWS KMS is a service that allows customers to create encryption keys and use the keys across over 100 plus AWS services with standard AWS API calls to protect your data at rest. In addition to being easy to use, which, all right, if we're calling something AWS easy to use, it must really be easy to use. AWS can be configured to encrypt resources by default for specific services. This means that your EBS volume, hard drives, but of course, AWS has to have a weird freaking way of referring to them, and S3 buckets, which are data storage containers, can be encrypted with keys AWS manages on your behalf if you don't configure customer managed keys. Amazon Certificate Manager. ACM is a service that provides SSL and TLS certs for encrypting traffic in transit. ACM will generate TLS certificates for domains where you control the DNS zone, allows the import or export of on-prem certs, and also allows you to manage a private certificate authority. AWS has integrated a number of services with ACM, which makes it easier than ever for users to implement point-to-point encryption. These services include Amazon CloudFront, Elastic Load Balancer, Elastic Beanstalk, their names, API Gateway, and more. This means you can use your custom domain certificates with a variety of deployable resources. All right, well, what does ACM provide? So let's see, Amazon Certificate Manager. I'm guessing the answer is that it provides SSL and TLS certificates. What does KMS allow users to create? Well, it allows customers to create encryption keys. What form of data is KMS responsible for encrypting? Well, it would be at rest. Even bolds it for us. What form of data is ACM responsible for? Will it be in transit? Accessing the environment, we already did that before the stream started, and I didn't run any errors. It said it created it properly. I may have to reconfigure my access keys on here. If I do, I have to stop sharing my screen. Otherwise, we should be able to use like the Cloud Shell and stuff. We'll see. Using the KMS service. Since a wide range of compliance frameworks, and here's the wide range, require or recommend encryption at rest for sensitive data, KMS is a particularly useful service for security teams. Furthermore, if you want to protect data confidentiality, encryption is essential. Orgs use the KMS service to encrypt various AWS resources, including EBS volumes, which is disk storage, for EC2 servers, S3 buckets, blob file storage, and databases associated with services such as DynamoDB and Relational Database Service, or RDS. Unfortunately, KMS can be misconfigured, like many things, to be overly permissive in ways that can reduce the effectiveness of the service. In this task, we'll look at how KMS can be misconfigured and how attackers would abuse this misconfiguration. Overly permissive AMS key policies. Each key generated by KMS has an associated key policy, so similar like an IAM policy. Key policies are a type of resource-based policy in AWS that allows permissions to the attached key without relying on another access control mechanism in AWS. That is, if your IAM principal is listed in a particular key policy, then you will have permissions against the key granted by the key policy, as long as you have permissions against the KMS service generally in your identity-based policy. By default, KMS provisions the following key policy when you create a key without specifying a key policy using the AWS API. So let's see if we can understand this. Our SID is enable IAM policies. Our effect is allow. Our principal, which is root, so it means a root is able to do this. And what can root do? What are we allowing root to do? Well, anything to KMSs and on any resource. So this is full admin root access. So by default, only the root user has these permissions. The key policy delegates the ability to provision access to this key for all principals in the AWS account, which is that one, via an identity-based policy. That means that any IAM principal in the account with permissions on this particular resource, which is the KMS key, will be able to perform whatever actions are delegated via IAM policy. So for instance, we have this version right here. Here's our statement. It allows, and what does it allow? Well, it allows the describe key, which is probably the list of keys, to generate data key, and to decrypt. And what resources? Well, we have the ARNs of the resources here that it allows it to happen. Grid Warrior over in the Twitch chat said he ran into this the other day. You can accidentally give your KMS key to every other KMS key in an account. Very interesting. So from Twitch, a real world example of how this can be misconfigured. So then you can imagine if you compromise one KMS key and that happens, you can now compromise that other KMS key and begin to elevate your privileges and kind of dig around the AWS account. For instance, and then it gave us this, is an IAM policy that can be attached to any IAM principal. Once attached, if the listed keys of that, these are the listed keys right here, the specific keys, delegate their resource-based policy to the AWS account that, then any IAM principal with the above policy attached would have permissions to describe details about the key, generate data keys to encrypt data outside of KMS, and decrypt data encrypted with the associated keys. So you can imagine how that could be abused by an attacker. While this is not an inherently insecure method of managing KMS key access, if you are an attacker with permission to create or modify IAM users or roles, you may be able to create an IAM principal and attach such an IAM policy to provide yourself with access. Actually, a cool way of doing that, maybe like a future Cloud Goat scenario. Practical for KMS, overly permissive KMS key policies. If you're using AWS Cloud Shell, you can access your terminal here. Once you've logged into your TryHackMe AWS environment for this room, you have been assigned credentials that allow you to create a KMS key. You can create a key by that. So we can use Cloud Shell. If it doesn't work, we'll switch over to the attack box. So AWS KMS create key. Okay. So it created it for us, and let's see if we can understand what's going on here. It gives us the key metadata, so it tells us what account ID this key is in. It gives us the key ID right here. It gives us the ARN, and then it gives us some information. The creation date, whether or not it's enabled. We could have added a description. What can the key be used for? It can be used to encrypt and decrypt data. Whether or not it's enabled, the origin, the key manager, customer key spec, the key spec, encryption algorithms, multi-region. Okay, cool. All makes sense. I'm guessing this information right here might come up. I'm just going to pull up Subalon here, and we'll use this just to record some of our notes as we pull up this data, because I'm guessing it might come in handy later. Now that you've created a KMS key, you can use this key to encrypt data stored in AWS as well as outside of AWS. Let's use it to generate a data key you can use to encrypt data outside of KMS. You can create a data key by running the following command. All right, AWS KMS generate data key, and then we want to pass it our key ID right here. Number of bytes, 16. Oh, that was supposed to happen. Okay, cool. It appears our user can create KMS keys, but we don't actually have permission to use them. Interesting. While this isn't a common policy, meaning it isn't common to be able to create a key but then not use it, it demonstrates for you what it's like to not have sufficient permissions when using a KMS key. If your user has IAM permissions that allow you to create a role or user with additional permissions, you can then use the permissions of your newly created role or user to gain additional access, including the ability to use the key you created or any key that has the default key policy. This transitive property of access, where you may be able to create another IAM principal that has additional permissions your IAM principal doesn't have, is a privilege escalation vector in AWS. Check out the IAM privilege escalation module for more information on this topic, and I think that's a future module that will be coming up. So does that principal, which is root, allow access to all users in the account or one user, the root user in that account, to access the resource? Well, it would be just the root user, right? Is it all users? No, why? Does the principal allow access to all users in the account or one user, the root user? Why is it all users? Guys on Twitch, enlighten me on that. So I think it's referring to this policy right here. When I read this, I mean, it explains it right here, I guess. It says this means that any IAM principal in the account with permissions on this particular resource will be able to perform whatever actions are delegated via IAM policy. And Meatman said it might be because all users can create the key but can't use it. Yeah, I suppose. I'm just kind of confused on that. Like, when I read this policy, and I obviously am reading the policy wrong. When I read this, it seems like, hey, we're allowing what? What are we allowing? What principle? Well, we're allowing the root principle to do what? Well, anything with KMS, which makes sense. That's how I'm reading it. Clearly, that's not the right way to read it. Amoeba Man said, but I'm guessing AWS is weird. Yeah, it is freaking weird and confusing. And, like, this is why AWS security is such a big deal. Like, we're trying to learn how to hack AWS, and it's confusing to us. But think about the defenders. They make one mistake. That's all they need to do is make one mistake, and you just open a door for a hacker. And I think that's why AWS pen testing or auditing, whatever you want to call it, is so important because misconfigurations happen all the time, partly because it seems to be overly complex. KMS encryption and ransomware scenarios. Ransomware and KMS cross-account keys. I didn't even think about that, using that to ransomware an AWS account or something. While KMS is a service that is intended to improve security for orgs, it does have capabilities that can be abused by attackers. In particular, KMS keys can be used cross-account. This means that a KMS key created on one account may be used to encrypt and or decrypt resources in another account, as seen in the diagram below. I see. That's very interesting. When both accounts are controlled by the same owner, this is a useful feature. However, when an attacker gains access to an AWS account looking to perform ransomware activities, bringing their own KMS key comes in quite handy. You see, an attacker can create a KMS key in an account they control, even like a free tier account, and if they gain access to a sufficiently privileged IAM principal on a victim account, they can provision temporary key access to the control principal in order to encrypt data in the victim account. You can see below what this looks like in practice for our example S3 bucket. So here's our attacker-controlled account, here's our victim-controlled account, and we have the attacker-controlled IAM principal we took over, and we can freaking encrypt. Oh my goodness, I'm curious, has this happened? Why Bing? I always set up a new profile, AWS KMS, for streaming, so there's not much on here. Oh my goodness, would you look at this? Rhino Security Labs wrote a blog all about this. So through our cloud security research, we at Rhino developed a proof of concept cloud ransomware using KMS to encrypt objects within Amazon S3 buckets of a compromised AWS account. Yeah, I'm telling y'all, Rhino Security Labs is ahead of the game, obviously. This is probably an older article even. I want to just skim through this. For those unfamiliar, S3, blah, blah. AWS Key Management System is essentially a managed encryption key service offered by AWS. So S3 buckets, they're not automatically server-side encrypted. S3 objects, KMS encryption. In that case, a user tries to view a file, would need the S3 get object, proper implementation, etc., etc. Here's the attack path. Attacker creates a KMS key in their own personal AWS account, which is exactly what TryHackMe is talking about. Maybe they use this as a source as they were writing this. And provides the world access to use that KMS key for encryption. No, I work there. I don't need to subscribe. This means that it could be used by any AWS user role account to encrypt but not decrypt. The attacker identifies a target S3 bucket and gains right-level access to it, which is possible through a variety of different means. This can include poor configuration or an attacker gaining access to AWS environment itself. Attacker checks the configuration of the bucket to determine if it's able to be targeted by ransomware. This would include checking if object versioning is enabled and if MFA delete is enabled. If object versioning is not enabled, they are good to go. If object versioning is enabled but MFA delete is disabled, the attacker can just disable it. If both are enabled, it would require a lot of extra work. Remember, defense in depth to be able to ransomware the specific bucket. The attacker uses the API to replace each object in the bucket with a new copy of itself, but this time it's encrypted. And then they schedule the deletion of the KMS key that was used for this attack, giving a 7-day window to their target until the key is deleted and the data is lost forever. Wow. An attacker uploads a final file such as ransomnote.txt without encryption, which instructs the target on how to get their files back. A following screenshot shows an example of a file that was targeted for ransomware attack. As you can see, the account ID that owns the KMS key that was used to encrypt is different than the account ID of the account that owns the object. The next screenshot shows what happens when the object owner uses a pre-signed URL to try to view the object. Access is denied because even though the object owner has permission, they don't have access to use the KMS key. To test this attack and see the viability, we ran Rhino's internal tool against an S3 bucket that was hosting approximately 2,000 different files of different sizes, totaling about 100 gigs of data. To ransomware the entire bucket, it took 1 minute and 47 seconds. Typical CloudTrail logs take up to 15 minutes to be delivered to an S3 bucket, but in testing it was found that CloudTrail S3 was delivered in approximately 5 minutes. Logs delivered in 5 minutes is much better, etc., etc. The next thing to consider is how fast you can react once you see what's going on. So we have a proof of concept on apparently Rhino's GitHub that does the following. Gathers the first 100 objects in the bucket, one by one overwrites each object with a, oh my goodness. To use a PLC script, modify the values of the CLI profile, bucket name, and KMS key ARN to match your environment. You think TryHackMe is cool if I do this? Just kidding, I won't do it. And so we can see what it's doing here. We're passing it the CLI profile. So that's after you configure your profile like a name profile. We're giving it the bucket name to attack. We're giving our key that we created in our own account. So this is the attacker's key. And we are creating a session with our profile name. We're setting a client variable with our session client for the S3 bucket. We're taking each one of the buckets. We're doing max of 100. Whoops. And then for object and object. So we're doing a for loop here. And we're going to copy the bucket name and the key. And basically what we're doing is replacing each one of those objects and saying encrypted. Here's the length, so the number of objects that we encrypted. Wow. That is cool. A meme man in the chat said, the interesting question here is what happens if you report the ransomware to AWS? Can they? Because I'd be more concerned if they can reverse this, since it means they have access to the keys, which beats the purpose of encryption. That's a great question. A meme man said, or can they hack the hacker's account to get the key and that way it's legitimate? Well, I mean, here's the problem, at least with this way of doing it, right? Once you do it, at least in the description, they said you schedule the KMS key to be deleted in 7 days. So they would have 7 days to get that key. And I guess if they don't, if the key is fully deleted, the data can't be recovered unless AWS has some secret backdoor, right? Wow, very cool. And once again, kudos to Rhino, the best pen testing firm in the world, that we discovered this article by Rhino. I don't think it has a date on it, but before my time, a bunch of cool stuff here. So hey, y'all, check out the Rhino Security blog. Here, I'll even drop it in the chat. That's the AWS research. Let's actually just glance at it. What do we all have here? I know we just came out with a brand new tool right here. And I think there's a Cloud Goat scenario being created as well that I will eventually stream in the future. But a lot of really cool original AWS research that you can see even matches up with what we're doing on TryHackMe. And so this is going to describe basically what we just went through on that blog. They must have like used this blog, it would seem to me, right? Because it says first an attacker would decrypt the objects in the S3 bucket. Their iron principal would need sufficient privileges. The attacker would then overwrite the objects in the bucket, but instead of using KMS key 1, the attacker would use KMS key 2, which only they control. Assuming the org didn't have object versioning and MFA delete enabled, which is what the blog post mentioned, the organization would lose the data immediately. Assuming the attacker controls a principal with KMS disable key and schedule key for deletion, the attacker could delete the key within 7 days. Oh my goodness, look at this, guys. I was right. So Rhino Security Labs got a shout out from TryHackMe on this. So amazing stuff. I was not expecting that. That just made my night. I'll make sure I tell the team at Rhino about this tomorrow. Very cool that we got that shout out. So once again, kudos to TryHackMe. I don't think they realized when they gave me access to the pathway that I even worked at Rhino Security Labs, but very sweet that we were mentioned in the actual TryHackMe path. What that should mean is like TryHackMe should give everyone at Rhino access to the AWS pathway, in my opinion. Oh man. Exciting stuff. How can you mitigate against the potential for ransomware encryption in S3? Well, it'll be object versioning and MFA delete, right? Because even the blog post said, hey, if you have those on, it's going to be a tough time. Amazon Certificate Manager, encryption certificates in AWS. Amazon Certificate Manager. KMS is intended to help AWS customers encrypt their data while at rest. Similarly, Amazon Certificate Manager, ACM, is intended to help AWS customers encrypt their data in transit with support for TLS certificates. TLS certificates are associated with specific DNS domains and/or subdomains. These certificates serve a dual purpose of encrypting traffic between the client and the server, as well as serving to enhance the reputation of the domain as it has an attached certificate. Though in 2023, most websites are using TLS. The important thing to note is as long as you control the associated DNS name or subdomain, you can generate TLS certs with the authority of that domain or subdomain. Let's take a look at an example. Drink of water. So here is our example. AWS ACM request certificate. We're passing it a domain name, which I must be giving it my account ID, bestcloudcompany.org, a validation method, DNS. All right, I think I can actually do that. So AWS ACM request certificate, domain name, and then we need to get the account ID. I'm guessing we don't want the dashes in it, right? My user is the account ID. I'm going to try that first. Okay, paste, please. There we go. Okay. It seemed to work. We are given the certificate. I'm going to save this to our notes. Maybe it will come up later. Once you have a response from the ACM API with a relevant certificate ARN, you will then use that ARN to validate your ACM certificate. What this actually means is to validate that you own or control the domain associated with the ACM certificate. You have selected to validate via DNS. You could also choose to validate via email. To validate the ACM certificate, you will need to create a record in Route 53, but first you will need to know what record ACM wants you to set. You can view this by running the following command. Okay, so AWS ACM describe certificate ARN, and then we're going to pass it this full ARN right here. Okay, so we are looking for what you need here. You need to know what record ACM wants you to set. So we have our domain name, subject alternative names. Our domain validation options are here. Domain name, validation domain, it's pending validation. Our resource record, our CNAME, all that good stuff. Okay. In this response, ACM has provided you with the resource record for the domain validation options. This record will be used to create a resource record in Route 53. First, you will create a file called acmrecord.txt with the following format. Use your resource record information from above. Then you'll copy and paste a version of this template updated with your specific details, name and value. Oh, hold up. So this is the acmrecord.txt. So what information do we need? The resource record set. Resource record right here. And so we need the type. Name from resource record's value from ACM resource record, which is that. So I think we just need this information here, right? We'll just grab all of this right here, and let's go ahead and drop it in our notes on the attack box. And then we're going to create this record. So let's actually create it here first so we can get all the syntax right. So here's going to be our file. So create a record for this. So let's go ahead and copy this from right here. All right, and then our validation domain. No, we don't need that. So here's the changes. What's our changes? We're going to create a resource record set, And then we want to pass it the name from ACM resource record. I think that would be this. Within the parentheses though. Okay. And then the type is CNAME. Yup. TTL 300 should be fine. Resource records value. And then we want to grab this value from right here. Okay. So let's go ahead and copy all of this. And then can I even like... It's broken. There. Can I actually create files here? Kind of a silly question. Oh yeah, okay, I can. So is nano a thing? Oh, it is. All right, in Cloud Shell. Beautiful. So we'll do nano acm record.txt. And we'll go over to our attack box. Let's just make sure we copy that properly. Paste. Don't ask me, bro. Cat ACM record. Okay. That all looks done, or looks correct. Once you've created the file, you need to find the Route 53 hosted DNS owning your account. This can be done by running the following command. And here is that information right there. I'm just going to copy that. In case it comes back up later, like in a question or something, we'll drop that in there. Then you can invoke the ACM record text file and hosted zone ID as parameters when calling the following Route 53 command. AWS Route 53, change resource record sets, hosted zone ID. And then we need our hosted zone ID, which I believe is this one right here. Change batch, and then file, and that's going to be our ACM record. Oh, add file twice. Error parsing change batch, invalid JSON, extra data, line 12, column 1, character 483. So that's in my record. Did I just have an extra space there? Oops. Line 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right there, there's an extra character. I followed that correctly, right? It's telling me this is the extra character, I think. What did I miss, though? I literally copy and pasted it. That EOF supposed to be there? I don't know. It seems like it is. I guess let's try to remove the EOF. Hey, I guess not. It seemed like it was like, I thought maybe AWS processed that in some way, but they must literally just be telling me that's the end of the file. I don't know why they included that. Just remove that. Whoops. I don't need to search it. Just, you know, in the text, in the code block here, just keep that. You don't need the EOF then. Seems to be working now, though. Then you may wait about a minute for your DNS record to propagate. Note that the status will change from pending to in sync when your request is successful. You can validate the DNS record propagated by getting the change information. And so that's that ID right there. So if we do AWS Route 53, get change ID, and it says ID from our last request. So let's go ahead and copy that. In sync. So that means that we're good, right? Now, when you run the previously used command again, so AWS ACM describe certificate ARN, which would be this right here. You should see the validation status change from pending to success. Validation status, it's still pending. Probably freaking did something wrong again. I just have to reset the shell. That like kills it when I run that. Chance Dye said, late to this session, but curious how you're able to subdomain bestcloudcompany.org. Is that a domain owned by the course that delegates to your zone, or how does that work? Yeah, I believe that's a domain owned by AWS because it's come up a handful of times so far, like in the learning path. Maybe it just takes a little bit for this to change. Although in their picture right here, it says pending validation. Let me try it one more time. Oh, all right, it's success. You guys see that? Just took a minute, so we did do it successfully. So you should see that change. Congratulations, you now have a certificate indicating you control the domain. There's that. You can use this with various AWS services to masquerade as that account ID, bestcloudcompany.org. Email users and other technologies to support allow listing may now allow you to bypass security controls anywhere bestcloudcompany.org is an allow listed domain. Very cool. What has to happen to your DNS record before the update takes effect? It has to be approved or in synced. Propagate. I wonder what answer looking for there. P. What has to happen to our DNS record before the update takes effect? Validation? What am I missing, Twitch? Is it just validate, maybe? Ah. Once you respond, so use that to validate. The validate comes up a lot. This seems to be the answer. Is it? Oh, it's not create a record in Route 53. Copy and paste the template. Once you create the file, you'll need to find the Route 53 hosted DNS zone. Then you invoke that file and hosted zone ID. Propagate is the only other one. It's either validate or propagate, but apparently neither of them work. Did I spell propagate wrong? Maybe that's what I did. Oh, okay, I was right. I think I used an O instead of an A, so I just need to go back to spelling class. Route 53 and masquerading is another domain with ACM. When attacking an organization, it may be particularly useful to impersonate a domain or subdomain hosted by them. In AWS, this is especially useful because of the services ACM integrates with, such as API Gateway, CloudFront, and Elastic Load Balancer. These services let you use the domain from Route 53 along with an ACM certificate to host custom phishing sites and/or malware payloads. I bet. Wasn't there a Rhino blog about that? Oh, that's CloudFormation templates. Never mind. There probably still is a Rhino blog about it, but while it is left as an exercise for the reader, these techniques may substantially improve the likelihood of phishing emails and download links bypassing email filters and other protections. This would be a very interesting lab to set up. This is because they originate from a trusted and in some cases internal domain. In the case of bestcloudcompany.org, that account ID is presumptuously owned by the same person or organization that owns bestcloudcompany.org. As organizations increase the robustness of their cybersecurity protections, controlling a trusted domain can be a tremendous springboard for attackers to gain initial access and get a foothold on trusted corporate devices. What types of sites can an attacker host with the control of a trusted domain and the associated TLS certificate? Phishing sites? There we go again. Another room, 2 rooms in one night. We have completed the AWS Encryption Services. Let's just see what we all have left in this pathway before I sign off for the evening for those of you on Twitch and those on YouTube. Look at that. We completed all of Introduction to AWS, all of Introduction to IAM, all of Attacking and Defending Core Services, and now we have a few of these, which I know Callie Max has done 2 or maybe 3 of these, so I need to check which ones he has done. But we will, ladies and gentlemen, we will have every module uploaded to YouTube step by step, working through this pathway. So for those of you on Twitch, thank you for taking the evening to hang out with me. I really do appreciate it. And those of you watching on YouTube, thank you for taking the time to watch another video. I hope you found it helpful. Hope you learned something through the process. I will catch you guys in the next one. See ya.